Today we are going to do experiment number 3. The title is Determination of the Molar Volume of Hydrogen Gas. In order to determine the molar volume, any gas, we have to use the STP conditions. The STP conditions are standard temperature, 273.15 Kelvin, and 1 atmospheric pressure. Now, in order to determine the volume, molar volume, especially in the case of hydrogen gas, we have to use a chemical reaction with a metal and a hydrochloric acid, which will really result in the release of hydrogen gas. This hydrogen gas is collected underwater in an inverted burette. The volume is recorded, the temperature is recorded, and the pressure is recorded. After that, the pressure is corrected for 0 at STP conditions, and so is the temperature. And then the volume is calculated at under STP conditions as V2 is equal to V1 times P1 over P2 times T2 over T1. Once this is done, then we have to, the volume that you obtain by using this expression is a result of the corrected volume, so that the total pressure when you are using, we have to do the total pressure correction by using Dalton's law of partial pressures. As the gas is collected underwater, the water vapor pressure at that temperature has to be deducted from the total measure to get the pressure of the dry hydrogen gas. And expression P1 V1 over T1 is equal to P2 V2 over T2 is the combined gas equation giving a relation between pressure, volume, and temperature. And so with that, I'm going to share my screen with you in order to perform the experiment. So go to the file, open the new document, and find the molar volume. Molar volume of the gas. Now, as you will see, as soon as the introduction is there, the metal that we use is magnesium. The balance reaction is magnesium plus 2 HCl, gives you magnesium chloride plus hydrogen gas. From this particular reaction, we see that for 1 mole of magnesium, we will obtain 1 mole of hydrogen gas. Now, knowing the mass of magnesium taken divided by the atomic mass of magnesium, we can obtain the moles of magnesium that was used. And this mole of magnesium used will also be equal to the moles of hydrogen gas produced. But the hydrogen gas produced here has to be for dry hydrogen gas. In order to get the answer for the dry hydrogen gas, we use Dalton's law of partial pressures, which says P hydrogen is equal to P total minus the pressure for the water vapor at the temperature at which the experiment was carried out. And below, you will see a table of water vapor at different temperatures. So you subtract that and you will get the pressure. Now you have the pressure, the volume is there, and the temperature is there. Once you get the temperature corrected, then we know P2, we know T2, P1, V1, T1, and therefore the volume for the given number of moles of magnesium metal that was used, we can get the volume. Once we get the volume, convert that by using the Avogadro's law. V1 over N1 is equal to V2 over N2, where N2 will be equal to 1 mole. And so we have to do the experiment. Now, in order to do the experiment, what we have to do is read up the procedure. There are 9 steps. Please make sure that you read it accurately. And also there is a pre-lab homework assignment for this so that you know how to read and take the observations and complete the calculations. Go to the equipment menu, beaker, take 600 ml beaker, click on it, and you have to add 600 mLs of 1 molar hydrochloric acid 600 mLs of hydrochloric acid, 1 molar into this. Then go to the equipment and get an inverted gas burette. There you have it. Click on it. Add the required amount of magnesium metal into the sample. I'm just putting in some number. So don't use my number, but I'm just demonstrating to make sure that you get the answer. Then invert this. Place the inverted bureau by select the inverted burette, add the metal, and then content menu, and then let's see. No. Then you combine it, and once you combine it, you click on it, fill the inverted burette. There you have it. And as the reaction proceeds, you can determine the volume. When all the metal has been used up and converted to hydrogen gas, remember to measure the volume by remembering that there is a slight assumption made here that there is no empty space between the tap and the bulb. And so you read the burette to the level at which it stops, and then you'll get the volume of the wet hydrogen gas, knowing the pressure of the dry hydrogen gas and the total pressure and the aqueous tension for water at the temperature at which the reaction was taken. You can complete the calculations as shown here. The actual atmospheric pressure is 102.9 kPa. That's a barometer. You subtract minus 4.2 kPa because this experiment is calculated under elevated conditions, and it gives you 98.7. You write the balanced equation, which is found in the introduction, from the mass converted to the moles. Again, already explained, you determine the moles of the hydrogen gas, and then you assume that the 100% moles of hydrogen gas is produced, and this is pure hydrogen gas. Look back at the introduction table and subtract the Dalton's law to calculate the pressure of pure hydrogen. It will be less than the pressure recorded. Calculate the volume that this sample of dry hydrogen gas would occupy at STP conditions. And once it is done, now you can see that there is no gas coming out. And so you go up from the top to bottom, reading 10, 20, 30, and so on. Please note that I have not taken the exact volume. So my exact mass of hydrogen, magnesium metal required for the experiment, but I'm showing you how it is done. Once it is done, fill in all the numbers and you can complete your experiment. Make sure to copy the picture of the experiment, initial and final, so that I can read the volume of the gas inside. Pressure is there, and complete it. And so complete the homework. Put your result, discussion, conclusion, homework, save everything and upload it into the correct Dropbox.